Welcome to another CATIA video. We're going to take a look at a DMU sequence mechanism. So the first mechanism will have a gear joint and the second one will have a rack joint over here. I will put the files within the video description, so let's see the final simulation within CATIA V5. We see that we're going to have two mechanisms, both will be angle driven. So in this case, where we have the motor, we are going to have the first gear, this will be angle driven, and for the second one as well, we'll control the rack position. So to get started, I will start from scratch. That means that I'm going to close everything. And we're going to see the files will be over here. Now, initially I will define an assembly. And within this assembly, I will select it, I will go to components, and I will add existing components. We could also make use of existing components with positioning. That will also define some constraints when the objects, the elements are added. But for this case, I will just go like this. So let's take a look at the file. Will be this one, DMU Kinematics. I will go and use the preview thumbnails, in this case for large icons. And let's take a look. Within those files that you can download from GrabCAD, we're going to add the bottle, we're going to add the fixed components for the first mechanism, the large gear, the metric 8 bolt. The motor, we're going to skip this because this will already be added within the fixed part over here, as well as within this subassembly. We're going to select the neck holder, part 1 as well. This will be embedded within this subassembly. I will select the both small gears, so small gear and small gear trolley, the trolley, and also the trolley fixed parts. So these are the components that will be added. I'm going to hit open and all the elements will be loaded. Now, they won't be positioned within their exact position like with other assemblies. So to get started, I'm going to start and move some of the components. I'm going to make use of the snap automatically. And in this case, I will select the trolley and I will move it to the sides. I know that the bottle will be within this mechanism on the left, the large gear as well on the left. This will be the rack gear. As you can see, the name will be like that. I'm just gonna move it over here because it's actually the same gear also for this joint and for the other one. And we're also gonna have the bolt that I'm gonna move and the neck holder for the bottles. So these are the components. I'm gonna disable the snap automatically selected. And we can start positioning the components. So I'm going to define a fixed component for this large assembly entitled named fixed components. And afterwards, using the coincidence constraint, I'm going to position the large gear over here. I'm going to press Ctrl and Y to redo the last feature. In this case will be coincidence constraint, and I'm going to position this all the way to the flat table over here. I'm going to do the same with the small gear. So again, Ctrl Y to rapidly do the last feature within CATIA. Again, Ctrl Y, and we're going to add this coincidence over here. Now for the bottles, we need to have a total of 4 bottles. Therefore, I will select the bottle, press Ctrl plus E. This will be this one. So define multi-instantiation. And I will define a total of 3 additional new bottles. Afterwards, I will hit OK. If for some reason the alignment of the bottle is not the same, you can swap that over here within the reference. You can also increase the spacing, but I will just leave it like this since we're going to reposition those. And after that, I'm going to press again on coincidence, and we're going to position the bottles on the large assembly. Each bottle will also have a surface at the bottom that we can use to final, let's say, position that bottle onto that gear. So this is quite repetitive, but you can make use of the hotkeys in order to rapidly align those components. And we still have the last bottle with this axis. You will always find the axis over here on the width of the component, and afterwards we're just gonna have that surface. So all the elements of the first mechanism are properly defined. We can now go to the second one. So I'm gonna coincidence this with that. Again, Ctrl Y, and we're gonna position this as well. And now to make it easy for CATIA to position this, I'm gonna use the compass again, so snap to selected, and you're gonna see that this trolley should go over there like a puzzle. That means it should be rotated within this position. So I'm just gonna slightly rotate it close to the final position, and afterwards I can make use of the coincidence. And let's see, this edge should be coincident with the edge over here. And afterwards we can also add a plane. So this plane should be coincident with the plane over there. And we see that we're gonna have that position. Now, depending on the length of the bottle, this can be adjusted. So for this case study, I'm just gonna select the trolley and move it on the z-axis a little bit down. So this will be the axis. I'm just gonna slightly move it until this section will be close to that top area. So we see those two cutouts. Somewhere like this should be good enough. We also need to position the second gear over here on the motor. Now for the final position, I'm gonna measure this trolley. So that means I'm gonna make use of the measure between. From this section all the way over here, we're gonna see 40 millimeters. And if you're gonna measure this as well, we're gonna see that this will have 12 millimeters. So that means I need to make use of an offset between this one and that one of 1 millimeter, and that should center it, in this case, -1. And we're gonna see that that will center the gear. Now we're just gonna need to replicate, multiply once this bolt. So I have a total of 3. I'm just gonna delete the last one. And we're gonna start positioning these components as well, so that should fit over there. We can center both like this, and afterwards we just have the final position which will be this one, coincidence with that. Now we can also position those bolts. So we have the axis. We see that this has been reversed. That means I can go within that. It will be easier if I will just delete that, and I will slightly rotate that bolt. And afterwards we're gonna have that again multiplied over here. So I will delete this as well, so double click within that, have that deleted, multiply this once. Let's see where will the second one be added. So component to multiply will be this bolt, and we can define the axis like this. Now keep in mind that this model is not, let's say, at the true scale, so we're gonna have a little bit of collision between this bolt and that neck holder. I'm gonna position it like this, or I can move it even a little bit to the outside area so that it will be easier to work with that. So we already have the axis, which is for this bolt, and now I will define that this surface should match the outside surface. And we're gonna do the same for the other one over here. And we just have the last surface, which will be that surface with this one. So we have the components in position. Now, if you're gonna swap to DMU Kinematics, you're gonna see that within DMU Kinematics, we have the possibility to use the assembly constraint conversion. But in this case, since there are two mechanisms over here, CATIA won't be able to properly define those. So we can define multiple mechanisms over here, but as an example, I'm going to define a new mechanism. I'm going to define a second one, and now I will leave CATIA to auto-create. But as we can see, there are totally a number of 13 pairs of components, and I will go with auto-create. And you're going to see that they have all been resolved. That means that CATIA has converted the constraints within the mechanism. But all have been added over here to mechanism 1. We see the joints that the software decided to add, and there are, let's say, not pretty well defined. I have another case study on my channel over here. If you're gonna search for DMU Kinematics, this assembly constraint conversion. For some components this works pretty good, but for this one it doesn't. So over here the software managed to add those quite well for this mechanism, but since we are currently having a more complex mechanism, CATIA wasn't able to do that. Therefore I will just delete the mechanism created by that auto conversion, so delete all children for this. The same for the second mechanism, and we're gonna start from scratch over here. So before I'm gonna start defining various joints, I also want to check how the gears are interlocking. Therefore I'm gonna go over here. Afterwards I will go to the top view, and we're gonna see within the top view that over here we have some collisions between the large gear and the rag gear over here. Therefore I'm gonna slightly rotate the small gear. So I'm gonna snap automatically to selected with the compass. Afterwards I'm gonna select the small gear. And now I could rotate on this axis, but I can also right click on the red spot over there, on the red vertex. I can go to edit, and I know that this will rotate along W. Therefore I can slightly rotate this gear. Now I will position the gear over here. The models are not very accurate, therefore we're gonna see that some overlap will still remain within our model, but I'm gonna position them something like this. We can even go with a smaller value, for example 0.1, and in this case with 0.1 those will overlap like that. We can do the same for the other gear over here, but let me just check how they are interlocking now. And we see this is slightly misaligned, therefore I'm gonna go within edit, and I'm gonna select a different view. So in this case I'm gonna go, the left view will be this one from the top. So in this case it will be front view, and we're gonna have this view. We can also change views by pressing F4. We're gonna see that we can move the mouse within the viewport. Therefore we're gonna know that this will be the top view in this case, where we're gonna see the alignment of that. So I'm gonna go within the top view, which will be over here. Now I see that this rack joint is let's say, blocking the view. Therefore, I can just hide it for now. I also added Alt-V as a hotkey. This is similar to Fusion. I highly recommend that you use hotkeys. And now we see how this gear and rack will align. Therefore, I'm going to start to rotate this. So for the axis, we're going to see that if I'm going to rotate it on this axis, it will slightly move like that. So I'm just going to undo that. Even though I undo, the part is still in red. That means there's a local update within the assembly. So currently I am within Imagine Shape workbench. I'm going to double click on product 1, press Ctrl and U for update, or we can click on that. So we see update position, the gear rotated on this axis. Therefore, that was not the correct axis. So keep in mind when you are rotating components to always verify the correct axis. So I'm gonna rotate it back until we're gonna be within a normal view. So we see with 1 degree it should rotate like that, and this is again close to the normal view. We can also go over here for the absolute rotation, and I can add -90 and 0, and we know that if I'm going to hit apply, the model will be within the initial alignment. Even though I see there are some slight rotations over here, I'm just going to press F2 to check if we are within a different view. So if I'm going to go to view, we're going to have render styles, but this is parallel. Therefore, the object is slightly rotated. As we can see on the rack, with normal 2, we don't see the other, let's say, edge. But over here, for the gear, we're going to see that. So I will just slightly change this. We have the absolute values, and we see that for some reason the absolute values are okay positioned, but still the object is a little bit misaligned. Therefore, I'm going to slightly rotate this. So I'm going to go with 0.5 on that axis. Okay, so I will leave it like this, even though there are some slight misaligned components over there. In order to fix this, the easiest solution is to add some constraints and afterwards have those deleted. So to do that, I will go back to assembly design. We're gonna go to coincidence, and I'm gonna make this coincident with that. As you can see, those have been aligned, and we know that we had an offset between this face and this face. We see that there's already a constraint over there, so I'm just gonna have that deleted for now. Realign the gear over here on that. Afterwards, position it at -1 millimeter, and as we saw, the rack move in this case, so that is not what we want. We want the gear to move alongside the rack. Therefore, I will make that fix, and now with an offset I will calibrate this to be at 1 millimeter, and now it should be properly aligned. Therefore, I can have all of those deleted. I can go back to that view. Therefore, I can press F4, and if I'm gonna move around, but as we can see, since now I'm in assembly design, that won't work anymore. So if I'm gonna press F4, I'm not able to select those views. But if I'm gonna go back to DMU Kinematics over here, we're gonna see how we can manipulate that camera. Okay, so for some reason that F4 doesn't work anymore. Therefore, I will just make use of the standard views. So we have the left view and we have the right view in this case, which will be this one. Okay, so I see that the gear will be slightly rotated, so that's how the model was. It's not important to calibrate it. since the model has that that bend shape over there. Therefore, we are just gonna rotate it on this axis, which will be this one. So I will grab that axis and I will slightly rotate it. So I'm just gonna position like this. As we can see, this gear and the rack will be better, let's say, defined than the small gear and the large gear. Okay, now since we have all the elements aligned properly, this is why it's important. So for this section, if you wanna calibrate the exact alignment, you can do that easily using the compass. Now we're going to define the mechanism. So the first mechanism, I'm going to start with the fixed part. So we'll go over here to the fixed part. I will define a new mechanism. We can leave it as mechanism 1, or we can give it a different name. For example, bottles. I'm going to click OK. And afterwards, with the mechanism bottle selected, I'm going to move the cursor over the fixed component over here. Therefore, within the newly defined mechanism, this will be the fixed component for this bottles mechanism. Now we're going to have a gear joint between those two. Therefore, I will select the gear joint. We're going to have the gear defined as 2 revolutes. So in this case, I'm going to define the first one over here by clicking create. It will be the axis of the gear with the cutout over here from the table. And now we need to define the plane. We can easily just use an offset. So I'll use this and that and keep that minus 22 millimeters between those. If not, you can select the exact contact surface between those two. But like this, it will be, let's say, faster. And for the second one, I'm gonna hide the large gear and I'm gonna select the middle axis. Afterwards, the axis inside the gear. Now the top surface and the bottom, and again I will maintain that 22 millimeter offset. I will send the large gear back so we can see how that will simulate. We know that this has to be opposite, and for the ratio it will be 0.25. Now to define the angle driven component, since we have the motor over here, I'm going to define that angle driven revolute 1 will be the driven one. And afterwards we can click OK. We're going to have this notice that the mechanism can be simulated. Therefore we can start that bottle simulation. And I will go all the way to 360. Afterwards I will hit insert and I will check the animation to see if those gears are properly working. So as we added that opposite and that minus 0.25, those gears should work properly. And now for the first mechanism, we just need to add the other components, which will be the bottle. This will be set as rigid joints between the bottle and the gear. So I will just redo that for all components by using the hotkeys for the last feature, which is Ctrl and Y within CATIA. And now if I will try to simulate this, we're gonna see that all the bottles should move along with that gear. Okay, so we have the first mechanism defined. Now we have this neck holder that will need to be activated by the trolley. Therefore, I will show this. So we see that bottleneck neck holder over there. Now, for the second component, the workflow will be the same. Therefore, we need to define a fixed part. But this new fixed part will be created within the new mechanism, which I'm gonna call this. Okay. We see that this is the neck holder. I'm just gonna call this trolley. And for the trolley mechanism, the fixed part will be this one. So the sub-assembly that has this extruded part and the motor. And now we need to define the components over here. So as we can see, we have a gear joint and we also have rack joint. So for the rack joint, it will be very similar to the gear joint, but it will be on one side prismatic joint, which is this side with a trolley, and for the other one a revolute joint. So for a prismatic we need to define, as you can see, a line and a plane. I will select this line, afterwards hide that trolley, select the same edge on the cutout, afterwards that surface and the equivalent face on the trolley. So we have this defined. We also have the ratio over here, as we can see. So I'm also going to define the revolute, and afterwards we're going to see how we can change this ratio, which is currently set to 6.283 millimeters per turn. So for the revolute we're going to have the gear, the motor, and those two surfaces. This will be angle driven for revolute, since we have the motor over here. And for the ratio we have this define button, and if I'm going to click on this one, we're going to see that actually we need to define a radius, and that radius will give us a ratio. For this gear we already have a sketch over here with the outline of the gear, so I'm going to select that. We're going to see the radius will be 34, therefore that will be the ratio. I'm going to click OK. And now we just need to check the orientation, so the ratio will be either negative or positive. As this looks, it should be with minus. So I'm going to set this to minus, I will hit OK. We're going to see that, so the mechanism cannot be simulated. Why? Because the joint was created over here. So I'm going to select this. We're going to see that we don't have the possibility to copy this and move it to the other mechanism. So this should have been over here within these joints. So I can select that, grab it and put it over here on the joint, but we see that CATIA doesn't allow us to move mechanisms like this. So the only option in this case will be to have this deleted. Or let me see if I can somehow change the parent mechanism, but there are no options for that. So I'm just gonna delete that. We see that when I will delete it, all the children will be deleted as well, so some coincidence and offsets. And now when I define the rack joint, I need to select over here the trolley. So this was that initial mistake. Keep this in mind when you are defining multiple mechanisms within the same assembly. So define again those same elements, which will be those, the plane and the plane on the trolley, send that back, go with OK, create. Now for the gear, have that offsetted, define the ratio using the sketch. I will put a minus over here, and this will be angle driven. So now as soon as I will click OK, since this will be set to trolley, we're going to have the notification that the mechanism can now be simulated. Therefore I will check how that trolley mechanism will work. For example, if I'm going to rotate this 50 degrees, this should go all the way down. I just want to check how the rack and the gear are interlocking. So I'm going to play this animation, and we see the gear will rotate on this direction and the trolley will go downwards. So this is the correct orientation. Therefore having that ratio with minus is correct. Now we just need to add the neck holder and those two bolts within the same assembly, which will be done using the rigid joint. We know that this should be in the trolley, so this should be rigid to that. And we can make those either from the trolley or the neck holder, those two bolts. So we see that the mechanism can no longer be simulated. Why? Because I added it again over here within the first mechanism. So I will undo that. Keep this in mind, always check the mechanism where you are defining so that there won't be any problems over there. So now we don't have that error anymore, and again those two, but in the trolley. And we see that we have the notification that the mechanism can now be simulated. Therefore, I will select the simulation command over here. I will select both bottles and trolley for this. Click OK. And now we're gonna have all the controls overlapped. Therefore, we're gonna need to change them. So I put the bottles to the left, the trolley to the right. And let's see, for each gear we only have 360 degrees. Therefore, we need to increase the limit over here for the first one. To do that, you can go on these 3 points, and we have the highest values, 1440. And for the other one, we can keep it like this. So we see that this will be the, let's say, the first step. I would like the trolley to go down and afterwards go back. Therefore, I will add 50 over here. I will hit enter. We see that the trolley moved to the bottom. Afterwards, I will hit insert. The next step, we're gonna see the steps over here. So 1.0, this is the first step. For the second step, I want this trolley to go back to 0. So this gear will rotate back to 0. Hit insert again. We see those steps over here. And afterwards, we want to change the bottle. So this is the initial bottle, bottle number 4. I will also change the color of that bottle. So make it different. Okay, we see that we can change the color while we are editing the simulation. Let's see, graphic. I'm just gonna make that purple. But for some reason, while we are in simulation, we can't do that. Therefore, I'm just gonna proceed with the simulation. So I'm gonna make the small gear rotate 360 degrees. That means the large one will rotate only 90. So 360 over here. Hit insert again. We're gonna put the neck holder down, so 50, insert, 0, insert. Afterwards, you're gonna go to 720, insert, 50, 0, insert. Now 1080, enter, insert. This should be 50, insert, 0, insert. And you're gonna go all the way to the last one, which will be this one. And now 50, and now 0 again. So a total of 14 steps. If I will move the animation from the start using this jump to start button, I will change the interpolation so we can better visualize the simulation, and I will hit play. We're gonna see the first step will be the trolley. So this should rotate, that should slide down. We see now that 2 first steps were completed. The bottles will now rotate. The second bottle is positioned, and we have that movement for the trolley. So this is how you can control a mechanism made, so let's say an assembly that integrates 2 mechanisms. So the same principle will apply to more mechanisms within the same assembly. As you can see, one of the drawbacks is that once we started this simulation, we no longer have the possibility to change those colors. Let's see if I'm gonna go with material. No, that material won't be added. But we see that now we are going for the last bottle, and over here the animation should finish. So we have that. I'm gonna click on OK, and now I'm gonna try to change the color of this bottle. And as we can see, we can do that, but all the bottles will be linked because they are copies of each other. So keep that also in mind. And if you want to change the bottle design, for example, you can easily use Imagine and Shape for this. So let's see how we can change that. For example, for bottle 4, I will double click on bottle for over here. This will take me straight to imagining shape, since this was the last workbench where I edited some elements in CATIA. If you are in part design for some reason, you can easily jump to imagining shape by going to start, shape, imagining shape. And within imagining shape, I will select the Y and Z plane. I'm gonna make this to no longer be snapped over here. So with that plane selected, I'm gonna go normal to like this. And afterwards, if I'm gonna click on revolute, we're gonna see how we can have that bottle drawn. But we need to be aligned with the view. Therefore, I'm gonna go over here. So this will be top view, this will be back, and I will need to go in within the front view for this case study. Now, since this is aligned with the view, if I will go directly within Revolute, you're gonna see that axis, and if I'm gonna start clicking to add points, we're gonna rapidly trace a bottle. So we're gonna see that bottle profile appearing. For the bottom, if I'm gonna click on that, it should close that loop. So by clicking on this one, now it's also closed at the top. So if you no longer wanna have that closed at the top, we can click on that and make it only on the bottom. Afterwards, if I will hit space, we're gonna have that bottle traced over here, as we can see, and we can further change the bottles if you want to. We can just select those points and have them dragged. And since all the bottle parts are linked, so they were multiplied using multi-definition with Ctrl-E in assembly design, if we are going to change one, all of those components will act the same and they will all change back. So we can also change the scale of the bottle. So if you want more imagining shape videos, I have several of those on my channel, and I highly recommend that you're gonna check those if you wanna, let's say, model various elements. So I hope that you find this video useful. I'm gonna position a similar video to the left and a subscribe button to the right. So thanks for watching.